And finally, the last part of this lesson is using operations on radical expressions. So the first task we're going to look at is how to add and subtract, and then later on we'll go to multiplication. So let's discuss or review the concept of like terms. Now, what are like terms? If you remember, when you're doing polynomials, like terms are those that have the same variable and exponent. So here, like terms are those that have the same radical expressions. For example, 10 radical 5 and 20, they don't have the same radicand and index. The radicand here is 5, the radicand is 20. They both have indices of 2, so the index is 2 because it's a square root, and same is true here. But since the radical expressions are different, then they're not like terms. So how can we simplify them? Well, we have to find a way to make them similar, if possible. If not, then we're just going to leave them as they are. So can we simplify radical 20 in terms of radical 5? Well, 5 is a factor of 20, isn't it? So that means we can write radical 20 as square root of 4 times square root of 5. But the square root of 4 is 2. So 10 radical 5 plus 2 radical 5. So now they have the same radical expressions. They are now like terms. So you can think of this as 10x plus 2x. So if you add them, it will become 12x. But here, we don't write 12x. Instead, we write 12 and then copy the same radical expression, radical 5. So this is the final answer. Okay, well, let's take a look at this example. This one is pretty much, ready for simplifying, right? Because they both have the same radical expression. It's cube root of x. It's cube root of x. So that means we could just combine the integer parts. So 6 and 2. So that becomes 8. So 6 plus 2 is 8. And then we copy the same radical expression only once. So that's the final answer. Let's proceed and look at some more examples. Okay, well, what about there's 3 of them? What's going to happen? So let's see. 2 is a factor of 6, right? But even if I break down radical 6 into radical 3 times radical 2, we still can't combine the radical 3 with the integer 10 and the integer 3. So that means there's no point in simplifying it, right? So what we're going to do is we're going to leave radical 6 by itself and combine those that have the same radical expression. So what is 3 plus 10? That's 13. And then bring down the same radical expression, which is radical 2. Now, since negative radical 6 has no partner, then we're just going to leave it as it is. So this is the final answer. We cannot combine these two anymore because they are not like terms. Let's look at this example. These two have the same radical expression, so they can be combined, right? This one, we leave it as it is, so we copy it. That's a radical 11, and then what's 5 minus 8? That's negative 3, and then we bring down radical 7. Now maybe you're wondering, what order I'm following, because here I combined first before I copied the expression that can be simplified. Well, here I copied this one first and then I simplified. Well, it doesn't matter because adding and subtracting radicals, the order in which they appear does not matter as long as, the answers take their signs with them. So, addition is commutative. Subtraction is not necessarily commutative, but as long as you put the correct signs for the answers, then you can switch the order around. Okay, next. Ooh. 7 and 63. Is 7 a factor of 63? Yes, it is. 9 times 7 is 63, right? And we know that 9 is a perfect square, so let's do that. 4 radical 7 minus 6. So we're going to break this down into 7 times 9. Okay? But what's the square root of 9? That changes to a 3. But where does the 3 go? The 3 gets multiplied to the integer. Okay? So 4 radical 7 minus 6 times 3 is 18 radical 7. So now subtract the integers. 4 minus 18 is negative 14, and then you bring down the common radical once. Alright, oh, these two are pretty much, like terms, so they're ready to be simplified. 4 minus 11 is negative 7, cube root of 5x. So that's how you add and subtract radical expressions.